So binomial probability is a way of figuring probabilities for something that has either success or failure or has only two options. The bi part means there's two options, okay? You're going to need to be able to eventually calculate binomial probabilities. It says using combinations, but in using, at least at most, you can use the, I'm going to teach you to do it on the calculator, okay? There's a binomial. This is the formula. Let's fill in what you have on your sheet to get started with, okay? A binomial experiment consists of n independent trials in which there are only two outcomes. Now, when it says in which there are only two outcomes, it doesn't necessarily mean there's only two ways something could happen. It just means you have to be looking for only one of two things, for example, success or failure. So, there we go, my pen. All right, the probability of success is going to be called P, and it has to be the same in every trial. So you can't be talking about something like with replacement or without replacement, I mean. The probability of failure is Q, okay? It's called Q. So the probability of success, I don't know why it lists this again, is P. And the probability of failure is Q, but Q is equal to 1 minus P. So if the chance we win is 30%, the chance we fail is 70%. Does that make sense, guys? It's the opposite. Okay. So what is the experiment randomly selecting a month 30 times? We want to pick January. Everything else would be not January, would be a failure. So the probability of picking January would be 1 out of 12, and the probability of not picking January would be 11 out of 12. Does that make sense? Randomly selecting a card 10 times, 100 times, what is the chance we get a heart? Well, there's 13 hearts out of 52 cards, or 1/4 of the cards. Does everybody okay with that? There's 4 different suits. Hearts is one of the 4. And not a heart would be what then? 3/4. Yep, that's it. So far, we good? All right, a binomial experiment has n trials in which P is the probability of success and Q is the probability of failure. Then the binomial probability that there can be exactly R successes is, and it's this crazy formula. You do n combinations of, let's see, what are we using to be, how many successes we want to have? N trials in which P is the probability, R is the number of successes. This is how it looks in our calculator anyway. And then you would multiply it by the probability of success happening R times and the probability of failure happening the rest of the time. Okay, so that's the crazy formula that goes in that box. These are all multiplied. There is a button on our calculator that'll do this for us without quite so much pain and effort. But we're gonna try it the long way a couple times first, okay? Again, P is the probability of success and Q is 1 minus P, or the probability of failure. N is the number of trials or experiments, which it said right up here, okay? And that's the word it's going to use on your calculator is trials, number of trials. X is the number of successes in this one. Ours had R as the number of successes, okay? All right. Mark tosses a coin 25 times, so that's our number of trials. What is the probability that it lands on heads? What's the probability it ever lands on heads, guys? 1/2 is our probability of success. What's our probability of failure in this particular one? Also 1/2, right? Okay, we want it to land on heads exactly 7 times. So that's going to be R, how many successes we want. So if we're doing this by hand, we do 25C7 times 1/2 to the 7th. And then the probability of failure happens to also be 1/2. And how many times do we want to fail, guys? Okay, failures is 18. It would be 25 minus 7. That's a minus, sorry. All right, so we grab a calculator, and under the math probability menu, we pick NCR, which is choice 3. If you have an older calculator, you have to put the 25 in before you ever go to that place. And then we wanted to be successful 7 times, right? So that's that giant number. But I'm not even going to write it down. I'm just going to proceed to multiply it by 1/2, 1 divided by 2, or you can use 0.5 to the 7th times 1/2 to the 18th, which is really just 1/2 to the 25th, but most of the time the probabilities are different. They're not both 1/2. So we're doing it the way you would do any of them. Okay. So 1.4% if we move it over twice is the probability 1.4% of the time that we would get exactly 7 heads. All right, I need to put that on here so you can see how we type that. All right, number 2, the spinner below is spun 10 times. What's the probability that it lands on red exactly 6 times? Okay, so what's our number of trials? Okay, and how many times do we want to succeed? 6 is R. Okay, what's our probability of success? We want red. Is that what we want? Red. 1, 2 out of 6 for red, yes. And not red would be 4 out of 6. Those definitely reduce, but there's not a lot of point. You're still going to type the same number of things in, right? All right, so it would be 10C6 times 2, 6. How many times do we want to succeed, guys? 6 times. Times we want to fail. How many times? 4. Again, you can type up here 10 minus 6, but all right. So 10 math over to probability, choice 3, 6, and times 2, 6 to the, I forgot, how many times did we want to? 6? Oh yeah, duh, okay. 6 times the chance of failure, 4 out of 6 don't work, and we want to fail 4 times. You actually don't even need the multiplication symbols in there, and it will do it correctly. 0.0569, about 5.7%. Okay, and I will put that screenshot on here as well. All right, so those are the long way to do it. That's the actual, what the formula is. But because it is a formula, it is also typed into your, programmed into your calculator. Let's talk about why. If you know the probability of success, could the calculator find the probability of failure for you? It'd be 1 minus, right? If you know the number of successes, can the calculator be programmed to tell you the number of failures? Okay, so all we are going to have to put in is the number of trials, the probability of success, and the number of times we want to succeed. Everything else the calculator can figure out based on that. So let me go to this slide. It is under distribution because it is, that's where it's stored on. Okay, so it's second vars. And then what we want is towards the bottom of the list, if you want to memorize where it is, but I usually go up to find it. Now, it's binomial probability, and these are very different, B and P, okay? P is when you want a straight up number of successes probability. C is when you want it to add up all the probabilities. In other words, what is the chance I succeed 7 or less times? Then it'll add up all those probabilities for you, and we'll do some like that in a minute. But for right now, make sure you're picking A, the binomial probability. Is it A on everybody's? Anybody's call it anything else? Okay, so you need binom PDF. And like I said, number of trials, probability, and the X value, meaning the number of times you want to succeed. So let's real quick just check the last one we did. Can anybody remind me what it was? It was 10 trials, wasn't it? And the probability was 2/6 or 1/3, but we'll just put 2/6, it's fine. And we wanted to succeed 6 times, did I remember that right? Okay, and then we just hit enter a couple times, and we get exactly the same value, okay? So we're just checking that it's doing the same thing, much easier, right? Yes. Yeah. Okay, so Kate took a multiple choice test with 4 choices for each question. If she guessed the last 5 questions, what is the probability that she got exactly 3 questions right? Now, this doesn't sound like a binomial experiment because there's 4 choices. But really it is because she either got it right or she didn't. Okay, so don't get confused that it's not really a binomial, it is. All right, what is the chance? Took a test with 4 choices for each question. She guessed the last 5 questions. Okay, so there's 5 questions left. That's gonna be the number of trials. How many successes does she want to have? 3 successes, which the calculator calls X. And what is her chance of success? If there's 4 choices, her probability of success is, how many of them are right? 1 out of 4. Everybody okay? 1 out of 4 is correct. All right, so it would have, you guys can type it in the calculator, it would have been 5C3, 1/4 success 3 times, failure the remaining 2 times, okay? But on the calculator, it's binom PDF, and out of 5, where the success is 1/4, she wants to succeed exactly 3 times. So, second vars, up arrow, make sure you pick the right one. I already forgot, was 5, 1 out of 4, and 3, was that right, guys? Yeah. So 8.8, 0.0878 would round to 8.8%. Questions? So try the next one on your own. Randomly chooses a card from a deck 30 times. What is the probability that he gets a diamond exactly 4 times? So 30 trials. What's the probability of getting a diamond, guys? 13 out of 52 or 1/4, because it's one of the 4 suits. And he wants to get it how many times? 4 times exactly. If you want to cheat, you can bring down your last answer and just go back in and change what's happening here. this was 30, comma, 1/4, comma, how many times did he want to succeed? I already forgot. 4. So I just retyped it rather than having to go back in and find that silly spot. Basically 6%, 0.060. Everybody good? All right. I'm gonna let you guys finish the ones at the bottom, or at least I can come back and do some more, but I'm not gonna worry about them on the video. I'm gonna go to the back side. The back side talks about combined probability, and we're gonna do one by hand first, miserably. We're gonna do number 10. Carol randomly chooses a day of the week 6 times. What is the probability of choosing Tuesday or Thursday at most 3 times? So she is a winner if she chooses, out of these 6 trials, I'm not going to do these this way, but if she chooses it 0 times, or what else? 1 time, or 2 times, or 3 times. Does everybody understand? It says at most 3 times, okay? She wants to choose what day? She's got 2 winners out of 7 days. So that would be 0 times, and 5 out of 7 times she wants to lose. I'm not going to do them that way, but that's how we could do them. We could also do Binomial PDF. What is she doing again? I forgot. 6 trials. 2 out of 7 days are winners, and she wants to win less, at most 3 times. Does this look like fun? Okay. There's a way the calculator will do this for us, but it's a little tricky to remember what it does. Okay, the calculator will combine all of these from 3 on down, okay? 3 on down if you do the binomial CDF, okay? So when we go into the vars and we go up and we pick the CDF, it doesn't look any different, but it is combining the probabilities up to whatever we tell it, starting at 0. So I forgot how many trials? 6 trials. 2 out of the 7 days were winners, right? And we want it to combine all the way up to, from 0 wins up to 3 wins. So we put a 3 here. Okay. And I got 0.940, so 94%. This was 6 2/7 3, but this C means it did all of these added up, gave us this, and it was 94%. Okay. I don't want to take time to show you that it works by adding all those up. It's miserable. Okay. Let's see if there's one more like this. Let's look at number 12, and then I'm going to come back and talk about the other ones. Number 12, there are 7 boys and 5 girls on the debate team. Each week, one is chosen at random to lead the debate. For the next 10 weeks, what is the probability that no more than 4 girls are chosen? So we're a winner if we have 0 girls, 1 girl, 2 girls, 3 girls, or 4 girls, but no more, right? So that will add up the probabilities for us. So what is the number of trials? 10 weeks, okay. the chance of success, success is a girl, so girl 5 out of 12, right? 5 girls out of 12, okay? And we want no more than 4. So we're gonna do binom CDF 10, 5/12, and 4, and as long as we do C, it's going to add up the probability from 4 down. Okay, I forgot totally because my brain. 10, 5/12, 4, thank you. If you had a really old calculator, it would literally, you would just type it like this. Is anybody's calculator old enough that you would hit binom CDF and then it would just simply bring up a parenthesis, and you have to know that the next thing you put in is the number of trials, you put a comma, the probability of success, comma, the number of successes you want. All right, I got 59.1 if I round. Did someone else get that? Okay, now there's a trickiness when we don't want to add down. If we go back to number 9, it says Kyle tosses a coin 10 times. What is the probability that he gets at least 8? He gets tails at least 8 times. So he wants to know 8, 9, or 10 times. How could we find the probability that he gets at least 8? Well, we could do 10C8, the probability of 1/2, 8 times, win, lose 2 times, plus 10C9, 1/2, 9 times, 1/2, 1 time. Yes. Yes. Okay. So the idea that Jada said is what we're going to do to make this easier. You could do it this way, but if he wants to get at least 8, can we find the probability that he gets 7 or less and then find its complement? Okay. So basically it's because we don't want to add up. We do want to add up, but the calculator is adding down. We're going to say 1 minus the combined probability. It's yes. Does she need me to go? Where does she need me to sub? Yep. Yep, nope. Okay. Binom CDF, and it was 10, 1/2, and how many? We were doing 7 and down, right? We want to lose, basically, so we're going to say 7 and down, and then 1 minus that. So I can do it in 2 steps if you need me to. Binom CDF. Okay, I don't remember the numbers, guys. 10, 1/2, and 7. And because we're on CDF, it's adding up 0, 1, 2, 3, 4, 5, 6, 7 wins. So it's 94%, but we didn't want 7 or less. We wanted 8 or more. So we have to say we want the rest of that percent. Okay. Now, I could quickly, maybe, I don't know how quickly, show you that that is the probability of 10 1/2 8 plus, nope. Okay. 9. Ugh. 9 and 10. And then we would add up this number plus this number plus this number. So 8, 9, and 10 was this. Is that what we got when we did it 1 minus the 7? Okay. Yes, you could absolutely have put it in as 1 minus, and then, where was it? That one? Yes? And it would have given us that one. Yep.
Instead of doing the 1 minus, maybe it would just done binomial CDF and then taking that percentage of 100 minus that percentage and time.
But that's still going to add up 7 down. So we could, yes, we could have said we want to fail 7 or less times. Yes, you could have switched the probability to failure. That hurts my head. Yes, you're right, that should work. Okay. I'm going to keep going and do this last one. The soda company prints prizes inside their bottles. The probability of winning a prize is 1 in 3. Out of 8 bottle caps, so we have 8 trials, what is the probability of at least 5 winners? Okay. So at least 5 winners means we want 5, 6, 7, or 8 wins, right? So how could we do this? Well, what's the probability of success, first of all? 1 out of 3, right? It says 1 out of 3 are winners. Okay, so what are we going to do? If we do combined probability, it's not going to add up, it's going to add down. So how many do we want? If this is what we really want, we really want 5 or more. We're going to say, well, what's the probability of 4 or less? And then take that away from 1. Do you got it? 1 minus the binomial CDF of 8, 1/3, and 4 or less. I am going to go right here and change this to 8. And it was what? 1/3 and 4 or less. Thank you. Did someone else get that number? Okay. So 8.8%. All right. Who needs me to go back? I'm just going to go back and do one quick one, and then I'll stop the video. But let's see. We didn't do 5, 6, or 7. Somebody pick one. Do 5. There are 30 balls numbered 1 through 30 in a bag. One is randomly selected 12 times, so there's 12 trials. What is the probability of getting a prime number? Oh, love it. Exactly 5 times. So we want to win exactly 5 times. So therefore, it's going to be binomial PDF because it's just one win, right? 5 times exactly. And it's going to be 12 and something and 5. But we got to figure out how many prime numbers there are. Okay, most of you would forget this, but 2 is the first prime number. It's the only even prime number because 2's factors are only 1 in itself. 1 doesn't count. The definition of prime is a number 2 or greater whose factors are only 1 in itself. 3 does not have any factors. What else? 5, 7, 9 has factors. 11, 13, 15 has factors. 17 does not. 19 does not. What's the next number that nothing goes into? 23. It's always odd numbers except for 2, because everything else is divisible by 2, but 27 is 3 times 9, right? 29. Okay, there we go. That's all of them less than 30. So it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of 30 or 1/3 goes there. So this is back to PDF because we want exactly, we're not combining a bunch of probabilities, just one. And I already forgot what it said. Somebody tell me. 12, 1/3, or 10/30ths. And how many times did we want to get it? 5. 19.1%. Okay. All right. You can skip the other 2, or I can do them after I stop the video. I just want to put up here that the homework is 7 quick questions in Delta Math. Okay? Oh, can you, why is that so bad on that screen? Okay, you can see it on mine, so I'm gonna stop the video here. Hang on.